Hello guys, welcome to my channel. This is Uday Pandit and you're watching MEP Technical World. In this video, we'll learn about basically how to read the SLD drawing of the main LT panel. So in previous video, we have already discussed about how to read and understand the GA drawing of the LT panel, that is general arrangement drawing. Okay, so here we have a small parts of side view. So this is also we can say GA drawing. Previous video we have discussed all about front cover. In the front, what are the components and actually how bus bar is running through the inside the panel. So if you talk about side views over here, if you look over here, so this is the hook actually during the transportation, loading and unloading, during the shifting, this will help us. And another is over here, so this is the actually height of the panel, so which is 2375 millimeter, and the width of the panel is 1000 okay, so 1 meter. And this is the back door where with the hinges. Okay, if we open the door from back, you'll see the bus bar arrangement, even cable terminations of the breaker, which is, so this part is actually R, Y, B and neutral. So TPN bus bar you can see over here. So this is actually TPN bus bar. So R, Y, B and neutral. So R, Y, B is the three phase, then one is neutral, and from there you can see over here, this is the input of this breaker. So this is the breaker, let's say ACB, air circuit breaker. Okay, and then so this is, suppose this is the input bus bar, so power is get from here. Then over here we have a outgoing bus bar, so we can take the output from this breaker, outgoing breakers. So this is the termination bus bar. So again here will terminate the cable, so R, okay, so here will terminate like this, R, Y, B and neutral from outputs. From here you can take a cable to respective feeder. Okay, so basically this is the side view of the LT panel. So this is the earthing point where we can connect the earth strip. It can be copper or aluminium. Okay, and over here hood is actually ventilation, we can say. From here it will extract by fan. Okay, now finally come to SLD drawing. So basically this is the view of SLD, single line diagram of the LT panel. So we can learn the operation, even we can read the drawings through this SLD. So you can actually execute the work set aside as per this, when we can make the panel according to this. If we understand this panel, which is designed by electrical consultant, so if we look into over here, so this is the bus bar actually. So here this thick line is the bus bar. Okay, so this is the bus bar going to next phase, means another feeders. Now let's see the specs of the bus bar. What are the specs of this bus bar? So if you go into deep, so this is actually single line diagram, but we have to consider this single diagram as a TPN bus bar, three phase neutral bus bar. So over here it is indicated with the this line, cross line. Okay, so here you can see R, Y, B and red, yellow, blue and neutral phase. So this is actually running 4 bus bar like this, but in single diagram it is represented by one line for easier understanding. So over here suppose this is R, then Y, then B, and this is neutral. So in this way we have to assume while we are reading the drawings, studying the drawings. Now another is 415 volt 3 phase 4 wire. That means this is the three phase voltage, okay, that is phase to phase voltage, which is 415 volt, okay. So between two bus bar voltage. So if we R Y, so between R and Y, if we measure the voltage, it will be 415 volt. So that's the voltage specification of the bus bar. Now this is 3 phase and 4 wire. I have already mentioned this is the TPN. TPN means 3 phase neutral. So it will 3 phase and 1 wire will be 4 neutral. And this is the 50 hertz. So frequency of the system is 50 hertz. Now this one is load ampere. So load bearing capacity of this bus bar. So this is 2000 ampere. So this is the load current which can bear this bus bar, which is aluminum bus bar, okay, aluminum bus bar. And its, we can say, breaking capacity is 50 kA, 15,000 kilo ampere. So what, so it can withstand 1 second. So this bus bar can withstand 50 K, means 50,000 ampere for 1 second. It can withstand if any fault arises, if short circuit happen. At that time this bus bar can withstand 50 ampere, 50,000 ampere for 1 second. So this is the actually specs of the bus bar. So according to actually load, we have to select the bus bar size. Okay, so this is the 12,000, so sorry, 2000 ampere aluminum bus bar. Now come to feeder side. So first here we'll discuss about feeder 1. So this is the feeder 1 MCCB. If you look into this rating of this MCCB over here, so this is Q18 for feeder 1 and 3-fold MCCB, okay, and its capacity is 400 ampere and breaking capacity is 15 kA, means 15,000 ampere. And if you talk about its protection, then it protect with overload current, then short circuit current, then earth fault. So it has a micro release with shunt relay. So with the help of this relay, it will trip the MCCB. And here we have a major concern over here. These are ICS and ICU, which is both are 100%. It means it is best breaker, we can say. So basically, what is ICU and ICS? If we are going to purchase the MCCB or design the MCCB, then we always go for this one, ICS equal to ICU, okay, means 100%. That means ICS means service breaking capacity, short circuit current, we can say. That means if breaking capacity is 50 ampere, let's say 50 kA, okay, and then this is the ultimate short circuit current. This is the also 100%. So this is the actually design current, okay, designed breaking capacity. If short circuit happen, suppose between, let's say, R to Y, at that time what happened, let's say 15 kA ampere current flows for certain time. At that time it will protect the MCB, it will trip the MCCB. After that we can also use this MCCB. generally for 2 to 3 times. It depends upon the design. Okay, so better if it has a 100%, means both are 100%, ICS equal to ICU 100%, that means that MCCB is good. Okay, now over here, so this is the emergency push button. In case of any fault, any emergency, we can push this button to break this circuit, to trip this MCCB. Okay, and this is actually H1 is indicator, which is used for if MCCB is on position then on, if it is off then off, and S3 is trip indication. So these are the indicator for monitoring the MCCB, means breaker. And another part is over here, this is the CT, actually current transformer. So this is actually CT, that is used for metering purpose, to measure the current of this feeder. And this is the KH, means multifunction meter over here. So digital KH meter with RS485 port, means it is communication. You can fetch the data through this port. You can use the BMS as well. And over here we have another control MCB for power supply of this meter, so 6 ampere. Okay, now coming to this, so this is actually 4 bus bar vertical, R, Y, B, and 1 is neutral. And if we look over here, so this is for feeder 1, section 1, LT panel section 1, feeder 1, and the rating of the breaker is 400 ampere. We can connect the load up to 400 ampere. Okay, then the cable size for this feeder is 240 square mm of 3.5 core XLP aluminum armored cable. And then, so this circuit is used for, so let's say MDB1 smoke evacuation. Okay, so this circuit is directly connected with the smoke evacuation MDB, main distribution board, or we can say SMDB, and where the connected load is how much? Connected load is 133 kilowatts. So this much is load is connected on this feeder. So similarly, so feeder 2 of section 1 bus, section 1 of LT panel. Similarly over here we have a 160 ampere 50 kA MCCB, and then this feeder is going to use for mezzanine floor MDB, and its connected load is 78 kilowatt and maximum demand load is 46 kilowatts. So similarly for feeder 3 as well. So in this way, in section 1, this 4 feeder are connected. Now come to next page where we have another feeder, so feeder 5 of section 1 L. So similarly over here, similar as we have already discussed, so it is for similar for now section 2 feeder 1. Okay, section 2 feeder 1, feeder 5, then feeder 1, section 2 feeder 3, similar as over. Now next page, so again same as we have over here. So this is for is UPS supply. So second section feeder 4 feeder number, and then second feeder 5 feeder 3 feeder 1. This is for actually capacitor bank. Okay, so this is for capacitor bank, a PFC panel, that is. Then over here, this is again for 3 panel section 3 feeder 2. Then next page over here, again similar way, feeder 3rd over here, again we have a 400 ampere MCB. Okay, then 800 for firefighting panel, then MDB panel for feeder section 4 feeder 2, then for section 4 feeder 3. So these are the outgoing feeders for LT panel. And again, so similarly over here, so fifth section feeder 1 and feeder 2, so this is for rising main. And then 6 feeder 1, this is for a spare. And then 7 feeder 1, 7 feeder 2, so both are for this. Okay, so up to here we discussed about outgoing feeders, so how to read the SLD of this outgoing feeder of the LT panel. So hope you guys understand about how to read the SLD single line diagram of the LT panel drawing. So in next video we'll discuss about its incoming section, like DG, how DG incomers are indicated in the LT panel, and transformer and PLC section as well. So thank you for watching this video. Please like, share, subscribe, and also hit the bell icon so you'll get notification regarding my upcoming videos. Thank you very much. See you again in next video.